Hi guys, today we're going to talk about systems of nonlinear equations. Okay, think back to our worksheet from yesterday. It asked us in several different places to find the intersection of two systems, and we did use the calculator for that, like this. But in our last example, it asked us to do it algebraically. It asked us to figure out the solution algebraically. If you'll remember that from either in class or from the video that I'm sure you went home and watched last night. I really hope you did, because you're going to need to know how to do that stuff today. All right. On the first part, it says for each problem, sketch the graphs and find the solutions to the system by determining the intersection points. This is just basically, do we know how to use the calculator? Okay, so let's make a new document. No, I don't want to save the old one. And I want a graph. Okay. Please remember, when you come into class, when you grab your calculator, I want you clearing these every day. Okay, starting a new document every day and not saving the old ones. First thing, right out of the gate. I don't care if you make a calculator page or a graph page, but you should be clearing these every day. I did discover yesterday that most of you are not, so please do that. So on problem number 1, we need to graph both of these two equations in our calculator. Hopefully you could tell me before we started what shape both of those are. Anybody tell me what this first shape would be? It is a parabola. You can know that because it is something squared. No other exponents in the problem. Anybody tell me what the second equation is? It is also a parabola for the same reason. So we're going to have two parabolas going on here. Okay, so we have x squared plus 4x plus 5. Okay, so that gives me my first parabola. We're going to tab to enter our second parabola. X squared minus 2x minus 6. Okay, so the first thing I have to be able to do is sketch this graph from my calculator over to the paper. I'm not looking for perfection. I'm looking for something pretty close. 1, 2, 3. Let's see. 1, 2, 3, 4, 5. That looks like it crosses at about 5. So like right there. So maybe something like that. Okay. This one crosses maybe about right there. Crosses down here below where I can't see, so maybe like right there, and then 1, 2, 3 on the other side of 3. So it looks like it's going to go like this. Okay. Now, again, that is not perfect. I didn't ask for perfect, I asked for close, and that's pretty close. It's very ugly. Okay, I understand that, but get it close. Now we have to find the solutions. Where is the solution to a system of equations? Even if they're nonlinear equations, where is the solution? Well, the solution is where they cross. So the difference now is we have to figure out how many times do they cross. Because with linear functions, they either cross once, they don't cross at all, or they cross everywhere. Okay? Nonlinear equations is going to be different. How many times do you think these cross? Well, hopefully you can tell it crosses for sure right there. Okay? There's no other intersections on the graph. So what I need you to figure out is, are there any other intersections? Is this line and this line at some point going to cross? Well, hopefully you realize, since neither one of these have a multiplier of anything other than 1, or the fact that they're the same, that means these are going to kind of be parallel out here at some point. Okay, and these also too, because there's nothing making it flatter or steeper, so they are not going to cross again. This is the only intersection. So we can go to Menu, Analyze our graph, and find our intersection, number 4. Okay. I can move my left bound, move my line over here to the left side of this intersection and hit enter, and then move it to the right side of the intersection and hit enter, or click the middle click. And it tells me right here what that point is. Now, for me that's very hard to see, so I'm going to hit Control and then the middle click button, and I pull this over here to the side so I can see exactly what it says. Okay, and what I see is negative 1.83 and 1.03. And that is my solution. Okay, let's do another one. Number 2. I'm going to hit Tab to go back to my equations. I'm going to delete this one and hit Enter. And I'm going to hit Tab to go back to my equations and hit Delete. Sorry, and hit Enter so it's gone. Actually, I don't have to hit Enter. I can just start entering the new one. I can start a new calculator page every time if I want to, but sometimes it's just easier to clear the ones you have in there right now. This equation is negative x squared. As you're entering this, I want you to be thinking about what shape it's going to be before you hit Enter. So before I hit Enter now, what shape is this going to be? Well, I hope you realize it is a parabola, but because of this negative sign in the front, it is going to be a parabola facing downward, opening downward. Okay, and in fact, that is what happens. Now let's enter this one. Tab to get another equation line to come up. Negative 2.8x plus 9.76, and we get a line. Okay, so carefully, 1, 2, 3, 4. It looks like it crosses at 4, and then it looks like it crosses a little past 3. Looks like right there is where the vertex is. So I'm going to do that. So that's close-ish. Now the line. The line is kind of a problematic. I know that it goes like this, but I can't really tell how many times that intersects. Okay? So I need you to think back to geometry. It can intersect here either 1 time or 2 times. Okay? Control label. I want to move this up so it's out of the way a little bit. Let go. Thank you. I'm going to move this also so it's out of the way a little bit. Okay? It can either intersect 1 time or 2 times. It can't intersect more than that just because of the properties of lines and parabolas. Okay? And it's really hard to tell. We could zoom in and zoom in and zoom in and figure it out. But let's just go ahead and do Control. Where is it? Sorry. Not Control. Menu and analyze our graph. Okay? Intersection is 4. Our lower bound is here. Our upper bound. Notice when I scoot my upper bound, I haven't pressed Enter yet, but a point has appeared right there. Okay? As I scoot it over, no more points appear. So that is going to be our only point of intersection. Now that's kind of a little cheater way, and it's not actually always accurate. So you just have to be careful. You just have to use your knowledge of parabolas and lines to figure out how many intersections happen right there. Okay? Now I could go back. I could say Menu and Analyze Graph and find the intersection, and I can put this like right here on that dot and then scoot over for the upper bound, and notice no other dots appear right here, so I know that there's no other points of intersection. Okay? Let's do problem number 3 as well. Okay? Problem number 3, we're going to tab to get our equation line up and hit Enter so it goes away, and tab again so we get our line up. Back here to enter these 2 equations. X squared plus 4x minus 2 and hit Enter. And then we're going to tab and hit negative x squared plus 3x plus 5. Okay? Now, first one we didn't talk about real quick. Hopefully you knew that was going to be a parabola. Second one, what shape is that going to be? Hopefully you realize that it's going to be a parabola, but it's going to be opening upside down. Okay, so we do have 2 parabolas here. Alright, so we get those copied onto our graph. 1, 2, 3, 4. It's a little past 4. Right there. And then it crosses right here-ish. 1, 2, 3, 4, 5, 6. So it's pretty close to 6. Where the bottom is, vertex. We get that graphed on our graph. Then the other one is upside down. There. 1, 2, 3, 4-ish. And it crosses a little past 7, so it's somewhere up here. We get that on our graph. Okay, again, I know it's ugly, just get it close so you have an idea of what it looks like. Can you tell that this time there are two solutions? There's one down here and one up here. We have to find both solutions. Okay, so we're going to do menu, analyze, point of intersection. Got to put it on the left side of this intersection, or this intersection on here, and hit enter. And we need to move it to the right side. We can't move it all the way over and get both intersections. It'll find only one at a time. Okay, so we press our middle click to get our intersection, and it's down there in all that mess. So we're going to hit Control and click to get it and scoot it out here so we can see it. Okay, so we know that one of our solutions is negative 2.14 and negative 5.98. Okay, in problems like this, aren't you glad I'm not making you do this just by hand, because these are ugly numbers. Now, the problem with this next one is I'm not going to be able to see that point of intersection. It's not going to show it to me because it's not in my window. So I'm actually going to have to fix my window. All I need is my Y max a little bit greater. So let's just go ahead and make my Y max 10. Now I can see the point of intersection. Follow the same steps that I just took a second ago. Analyze graph, find the intersection, put it on the left side of the intersection and on the right side of the intersection, and we have our point. Now I can see that one okay. I'm not sure if you can. Let me scoot it down a little bit. Okay, that point is 1.64 and 7.23, and that is the second point of intersection. If there are two solutions, you have to find both of them. Don't just find one and think that's enough. Okay, so you have these 3 to do on the front and these 4 to do on the back back of the first page. Please understand you have to have a calculator for these, so please get these done in class. Okay, on the back page we need to do these with algebraically with substitution, like we did the problems yesterday on the worksheet that we did yesterday. Okay, I think it was number 8, something like that. So we're going to actually do number 11. It says follow these steps to solve number 9 algebraically. Compare your solutions with the calculators. Okay, now once you do number 9, this hopefully will make more sense. You'll realize what the answers are. I don't have time to do number 9 for you today or on the video, so make sure you get that one done. Okay, so in order to solve number 9 algebraically, we need to set the two functions equal to another. Okay, these two functions have to be set equal to each other. Y equals this and y equals this, so these two things should equal each other. So we have 4 over x minus 3 equals 2x minus 6. Okay, it says clear the fractions by multiplying both sides by the denominator. We can do that, or we can just basically cross multiply since it is two fractions set equal to each other. When we cross multiply, we get 4 equals these two things multiplied together. So x minus 3 times 2x minus 6. Okay, so we end up with 4 equals 2x squared minus 6x minus 6x plus 18. When we collect our terms, we get 4 equals 2x squared minus 12x plus 18. We need to set one side equal to 0. It is a quadratic, so we solve by setting it equal to 0. So we subtract 4 from each side, and we get 0 equals 2x squared minus 12x plus 14. Okay, and then we want to solve using the quadratic formula. You already know how to solve using the quadratic formula. I'm not going to take the time on this video right now to make sure you can do that correctly. We've done that many and numerous times. Okay, once you find the x value, when you get to the end of quadratic formula, you're going to get x equals something. You might get x equals 2 different somethings, and you probably will actually, unless it's exactly the same number. But you're going to have to substitute that value or those values back into the one of these original equations to find the y value. Because right now we don't have any more y's. We eliminated the y's when we set these two equations equal to each other. Okay. So once you find the y values, go back to these original equations here. It doesn't matter which one you choose, and substitute in x to find your y value, and you will get an answer that's either 1 point or 2 points, depending on how many x values you end up with. Okay, so that's how you're going to do these 4. And that's how you're going to do these 5 on the back. I will be here after school if you have any questions. Please behave for your substitute today, and have a good day.